Hi students, in this lecture I am going to discuss problems based on moment of inertia. Let us see first one. Let's see the question. Calculate the moment of inertia of a triangular plate about its base if m is mass of the plate and h is its height. Let us see. Right, see the first make a diagram. It is a triangular plate. Given mass is m, its height is h, and we have to find about its base. About the base, this is the axis. Then see what we can do here. So first we have to focus on how to take elements. Okay, this plate can be taken as now combination of rods, right? Rods of different lengths. I can say this is now one rod. This is one more rod, right? Rods of different lengths, and all rods are parallel to this axis. Let us take at some height, that is x. So take one rod, okay, taking one rod. Suppose this base length is b. Then this base length is taken as b dash. Okay. And this thickness that is equal to dx. So we have taken it is just like a rod of length b dash. Its width equal to dx, where dx is very small. Okay. Now you can see each and every point in this rod is at same distance from the axis, that is x, right? Then we can write its moment of inertia di is equal to, if its mass is dm into x square. Okay, because each and every point in this rod is at same distance, right? Okay, now focus how to get its mass. Given this height equal to h, okay, since it is a plate, two-dimensional body, we are focusing mass per unit area. Okay. So what we can do here, dm equal to m upon area. Area means it is a triangle, half base height. Okay. Next, coming to here, its area equal to length is b dash, its breadth equal to dx. Okay, that is now dm, right? So we can take here dm into x square. But in this, we are not given this b and b dash. Okay, then see what we can do. From similar triangles, this is a bigger triangle and this is now smaller triangle. In that we can write b dash upon b is equal to h minus x by h. Cross check once. B dash. This corresponding height is h minus x. So b dash by b is equal to h minus x by h. Okay, that we can use now in this. Right, now make calculation. I equal to integral di integration of, in the place of dm. See what we are writing here. 2m by bh in the place of b dash h minus x by h into b. Okay, into dx. This is only dm. Okay, C1's 2m by bh in the place of b dash h minus x by h into b dx into x square. Like this, we have take all rods from x equal to 0 to up to h. Okay. First make calculations is b gets cancelled. Take 2m outside, 2m outside, h and h square. Remaining is now h minus integration of h minus x, or you can say hx square minus x into x square x cube dx. Okay. Now see remaining calculation 2m by h square. This becomes now h into x square dx, x cube by 3. That is h cube by 3 minus x cube dx, h power 4 by 4. Limits 0 to h cube h power 4. Take outside h square. Remaining is h square. 2m h square. Remaining is 1 by 3, 1 by 4. Right? 4 minus 3, 1. This is a 12. So it is now m h square by 6. That is moment of inertia for a triangular plate about its base. Okay. Let us see next problem. Calculate moment of inertia of a disk of mass m whose inner radius is r1, outer radius is r2 about its own axis. Right? Now see the calculation, how to start it. Given this, it is a disk of inner radius. Disk of inner radius R1, outer radius is R. Okay, its mass is M. So we have to find the moment of inertia about its own axis. Its meaning is passing through center and normal to plane of the disk. Right? So now this can be taken as a combination of rings. Students, if you remember, while calculating I value for a disk, we have taken combination of rings. Exactly same thing. So where change comes. So we are taking a ring of mass. So take one ring. So we are taking a ring. So take a ring of radius smaller and this width equal to this width equal to dr. Okay. For that moment of inertia, it is now dm into r, right? Now in the place of dm, see what we can write. Dm equal to m upon, coming to area, it is pi into r2 square minus r1 square. Okay, this is a mass per unit area. Coming to area of this ring, that is 2 pi r into dr. The only change is earlier we have taken m by pi r square. It is now r2 square minus r1 square. Okay. Now see carefully. Pi gets cancelled. Substitute now I equal to integration of dm into r in the place of dm. It is now m upon r2 square minus r1 square into 2r dr. That is dm into r. Okay. So you can take constants outside. That is 2m upon r2 square minus r1 square. The remaining is now r and r square, r cube dr. So 2m upon r2 square minus r1 square. It is limits now, limits r1 to r. Earlier in that we have taken 0 to r, right? While making calculation for this. Okay. So it is now r power 4 by 4, right? Means 1 by 4 r2 power 4 minus r1 power 4, right? And 1 2 gets cancelled. This is equal to m into r1 square plus r2 square upon 2, right? So this I have taken as r2 square plus r1 square into r2 square minus r1 square. Okay. This is a final result. M by 2 into r1 square plus r2 square. Right. Let us see next one. Right. See the question given. A square plate of mass m and edge L is shown in figure. The moment of inertia of the plate about the axis in the plane of the plate and passing through one of its vertex, making an angle 15 degree from the horizontal is. So with a horizontal, this makes angle how much? 15. It is a square plate. Mass m, length is n. So we have to calculate now what is moment of inertia. Let us see how to start. First of all, make a diagram. It is a square. It is a square. Right. Now you can see this makes an angle. This makes an angle 15 degree. Okay. That means see what happens. If you are taking one diagonal here, diagonal, one diagonal, it is not normal to this. Okay. If this angle is a 45, this will be normal to diagonal, right? Now it is not normal. So if you want to draw normal to that axis, if you want to draw normal to that axis, so that will make an angle. That will make an angle 30 degree. This is now normal to that axis. Now see carefully. Let us take one, imagine one line passing through center. Okay. Now you can see this is 90. This is 90. Now see what we can say. In case of a square plate, in case of a square plate, suppose we are taking one axis which is a passing through center like this. Diagram is not exactly correct. Right. Or do one thing here. Imagine one diagonal here and take one more. If you call one of them as x-axis, other one as y-axis, okay, then ix is equal to iy, because about x-axis and about y-axis, I value will be same, okay, which is equal to ml square by 12. Okay. So now what I'm saying is rotate this axis. Okay. When we rotate now these two axes, still Ix and Iy will be same, which is equal to ml square by 2. Okay. So if you are taking now Iz is always equal to Ix plus Iy, which is equal to ml square by 6. So here what I am saying, if we rotate these two axes by any angle, still these two are equal and that value equal to ml square by 12. This result we are going to use now in this problem. So here, this is now diagonal. I can take here one more diagonal, right? If we rotate now this diagonal by some angle, it may be 30 or it can be any angle. Still, about this axis, this is the axis passing through center of mass. About this axis, that value will be ml square by 12. So I hope you got this point. So here about this diagonal or about this ml square by 12. If we rotate these two axes by any angle, still their values do not change. That result we are taking now here. Now this is a parallel to this axis. This is parallel to this axis. This is now i's. Okay. So now we can take, if this is I, we can write now I equal to IC plus mx square. Distance how much? Let me take this as A. This is B and this is now D. So we want to take now distance, that is AD. And AD value how much? In triangle, if you take right angle triangle ABD, in that AB will be hypotenuse, right? And AD will be adjacent side. That means AD value will be, see how much? AB cos 30. AD equal to AB cos 30. And AB value how much? It is a half of the diagonal whose value is now L by root 2. Half of diagonal L by root 2 cos 30 root 3 by 2. Substitute here IC plus mx square L by root 2 into root 3 by 2 whole square. Okay. And IC value how much? ml square by 12. ml square by 12 plus m into, see how much? 3. This is a 4, 4, 2, 8. Right? ml square, you are having 3 here. 3 by 8. Let me cross check once. L square 3. This is 3. Right? 2 square 4. 4 2 8. Now simplify this. How much we get? We can take ml square outside. Remaining is now 1 by 12 plus 3 by 8. See how much we get? 8. 8 plus, this is how much? 36, right? 36. 36 ml square into 8 plus 36, 44. 44 upon 12 into 8. Okay. And see calculation part. 4. 11 times and 4 here 3 times. It is 11 ml square by 24. Okay. So main thing we have to focus, this is parallel to which axis? And here key point is that when we rotate this axis by any angle, their values again same only and equal to ml square by 12. Okay. If you know that key point, we can solve this problem. Let us take next one. Right. 1/4 section is cut from uniform circular disc of radius r. This section has a mass capillum. It is made to rotate about a line perpendicular to its plane and passing through the center of the original disc. Its moment of inertia about the axis of rotation is, asked in 2001, mass is 1/4, right? Its mass and radius is r. It's very simple one. See once. Given it is 1/4, its mass and radius is 1/4 means for total one mass will be, for total one mass will be 4m, right? About its own axis. If you see about own axis, it will be total mass into r square by 2, right? This is about its own axis. Total mass 4m. So total mass into r square by 2. This is now 1/4. 1/4 means what happens? Value becomes 1/4. Okay. So 4 gets cancelled. So answer is mr square by 2. So it is very simple and direct one. Okay. It is the first option. And the next one, the moment of inertia of a thin square plate ABCD of uniform thickness about an axis passing through the center O and perpendicular to the plane of the plate is, asking axis passing through the center and perpendicular to plane of the plate. Given, okay, 1, 2, 3, 4, right. See what we can do. This also directly we can get the answer. So taking a square plate, passing through diagonals. So given 3, 4, 1 and 2. So here what we can do is about this axis, right? Through center normal to plane, call it as z axis. I z equal to. Suppose I am taking this 3 as x axis and 4 as y axis. It is equal to ix plus iy, means I3 plus I4, right? Or if you call it as 1 as x axis and 2 as y axis, then this can be taken as I1 plus I2. Okay. And here one more thing is I3 equal to I4, right? At the same time, I1 equal to I2, right? Sum of these two equal to IZ. Sum of these two equal to IZ. Its meaning is I1 equal to I2 equal to I1 equal to I2 equal to I3 equal to, sorry, I3 equal to I4. All are equal. All are having same values, right? Because X and this is Y. So I3 plus I4. This is X, this is Y. So I1 plus I2. Both having same values. Means all having same values, right? That means, see what we can say. We can say I1 plus I2 directly. I3 plus I4. Even we can say I1 plus I3. Or even we can say I1 plus I4. Get the point. You can take any of the combinations. 1, 2, 3, 4. Okay. Any of the combinations. 1, 2, 1, 3, 1, 4. Or you can say 2, 3, 2, 4. You can take any combinations. So answer is A, B, and C. Okay, you can take any two. That is answer. D is not the answer because you have taken 1, 2, 3, 4. Okay, that's why. So here you can take any two combinations. So final answer is A, B, and C. So ask for 2 marks in 1992.